Welcome to the notes on right triangle trigonometry. So trigonometry sounds really difficult. I hope after today's lesson that you realize it's not that complicated at all. Again, so trigonometry has to do with right triangles, okay? So again, this is for right triangles only. All right, keep that in mind when we're doing these. So first thing you need to know is a reference angle, okay? Depending on what our reference angle is, changes how we label these things. And honestly, labeling the triangles is probably the most important part of trigonometry. So in the first example, we're going to say angle A is our reference angle. So I'm just going to kind of circle it so we know that's the angle that we're talking about. Then all we've got to do is we just have to label three parts of a triangle. Okay, and it's a right triangle. So the first part we always want to label is the hypotenuse. So we know what this side is the hypotenuse because, again, it's opposite of that 90-degree angle. All right, so that's the hypotenuse. Then we've got to label the legs, which we already know what the legs of a triangle are, but we have to be able to distinguish them. We're not going to say short leg and long leg. We're going to say opposite leg and adjacent. So the leg that is opposite or across, all right, we're going to call the opposite leg, and the leg that's next to, we're going to call the adjacent. All right, I'll actually write that out so you can see it. Adjacent, remember that means next to. So this leg that's next to our reference angle is the adjacent. The leg that's across is the opposite. So that is the key to trigonometry right there. Let's do another example. This time we'll call our reference angle C. Okay, the reference angle. Okay, it's never the right angle. Just keep that in mind, all right? It'll never be the right angle. So it's going to be one of the acute angles. So in this case, it's C. Notice the hypotenuse is always the hypotenuse. Doesn't matter where our right angle is. The hypotenuse is always the hypotenuse. It's the legs that change. So now this leg that, again, is across, we call the opposite. And now the leg that's next to it is the adjacent. Again, adjacent means next to. So that's the key to labeling. So now that we know how to label right triangles, here is the phrase, all right, that we're going to use over and over, and I still use today. All right, SOHCAHTOA. All right, what does it mean? Okay, so, all right, what does that mean? That means to find the sine, that's what the S stands for, equals the opposite side over the hypotenuse. All right, the ratios of sides. To find the cosine, all right, that's the C in ka. All right, cosine equals adjacent. I'll just put an A over the hypotenuse. And then to find TOA is tangent. So tangent equals opposite over adjacent. That's what those mean. Okay, so now that you know, that's how we're going to set up these problems. And again, it's all based off your reference angle and being able to label the side. So here's an example now. I'm going to keep that SOHCAHTOA there so we can see it. So all of these notes, they're asking for the sine of A, the cosine of A, the tangent of A. That means that A is our reference angle. So the first thing I like to do is I like to label the parts of the triangle. I'd call this from A, I'd call this side the hypotenuse. This side over here is going to be the opposite side, our opposite leg, and then this leg is adjacent. So I've got them named. Now I just got to set up the ratios. So the sine of A. So sine again means opposite over hypotenuse. So when I look at A, the opposite side is A. All right, right there. All right, so I'll just put a little A. And then the hypotenuse is C. So the sine of A equals A over C. Cosine. All right, that's the adjacent over the hypotenuse. So from A, the adjacent side is B. And once again, the hypotenuse is C. And then the tangent, that's opposite over adjacent, TOA. All right, TOA, opposite over adjacent. So opposite is A, the adjacent is B. That's all I got to do. All right, you know your reference angle? Set them up using those ratios of SOHCAHTOA. Let's take a look at one more example here. I find the three trigonometric ratios for each acute angle. We're not going to do A. We just did one with A, but now let's take a look at when our reference angle is B. So you can see here, B, B, B. All right, so now we see our reference angle. Remember our phrase, SOHCAHTOA. All right, again, I use that every time. SOHCAHTOA. So to find the sine of B, all right, I'm going to look to the opposite side over the hypotenuse. So 9 over 15. So I'm just going to write 9 over 15. The cosine of B, well, that's the adjacent, which is 12 over 15. Ka, adjacent over hypotenuse. And then find the tangent, that's the opposite over the adjacent, so we can say 9 over 12. If you want to reduce those, you can. Right now, I'm just interested in you setting those up correctly. Now we know how to set it up. Let's figure out how to solve. So where's our reference angle? It doesn't say. Well, the reference angle is either going to be the angle that they give you, the measure of the angle, or it's going to have the unknown for x. So in this first example, here's our reference angle. So now which trig function do I use? Well, you're going to use the two sides that we know information about. Well, we know something about this side right here, and we know something about this side. So this is the adjacent side, and this is the hypotenuse. All right, so which one am I going to use? Well, remember, SOHCAHTOA. There's our phrase, all right? Adjacent hypotenuse, all right? That's right here. That's cosine. So I'm going to say the cosine of 39 equals adjacent, which is x, over the hypotenuse, which is 14. And then we're going to solve, all right? Remember, to solve any proportion, we cross multiply. So imagine I put a little imaginary 1 there, and then we just cross multiply. X times 1 is x equals cosine of 39 times 14. All right, when you type that in your calculator, again, cosine 39 times 14, all right, and that's going to be equal, x is going to equal, when you do that, you're going to get approximately 10.9, and that will be your answer. Let's take another look at another example. Where's our reference angle? This time, we're trying to solve for an angle. Remember, anytime we're trying to solve for an angle, we're going to use the inverse. The inverse. We're still going to use our same relations. What two sides, which function do we use, which two sides do we know information about? We know something about the hypotenuse once again, and I know something about that adjacent side. Let's put an A there. So once again, A and H, it's the cosine. But this time, I'm not going to do the regular cosine button. I'm going to do cos inverse because I'm trying to find an angle. Again, anytime you want to try to find an angle, use that inverse button. So I'm just going to type in cos inverse of adjacent, which is 16 over 21. I'm going to type that in my calculator. When I do that, you're going to get the answer of, all right, x is going to equal 40, we'll call it 0.4 degrees, 40.4 degrees. So there you see one with, we're trying to solve a side, there's one we're trying to solve an angle. Both were cosine. Let's do one more so it's not cosine. Here we go. Here's our reference angle. All right, we know this side right here is our hypotenuse. This side across is the opposite. So which one involves O and H? Well, that's sine. So sine of 15 equals the opposite, which is 5, over the hypotenuse, which is x. Again, this is really over 1, and we cross multiply. So when we do that, we get sine of 15, x, or x times sine of 15 equals 5 times 1 is 5. We're going to divide each side by sine of 15. Remember, that's a value. That's going to cancel out. Divide 5 by sine of 15. You're going to type that in your calculator. You're going to get x equals, and this one comes out to be about 19.3. So there you have your lesson on trigonometry, how to label the sides and how to use those sides with the phrase SOHCAHTOA to find for missing values. Remember, if you're trying to find for an angle, use the inverse button.